So let's take a look at an example on how to do homogeneous differential equations with constant coefficients. All right, so it's homogeneous. What we're going to look at is homogeneous ones, and so that means that they're going to be set equal to zero. Right, so we have this thing equal to zero, and they're going to have constant coefficients. So let's look at one that's got 6d squared minus 1d minus 7 equals 0. Okay, notice here are the coefficients in front of each one of those derivatives. Okay, they are also constants. So given that they're constants, what that allows me to do is it allows me to basically factor out the differential operator. So this is now going to be 6d, right, minus 7 times d plus 1 equals 0. Okay, so that's how we're going to write it. Then what we're going to do from there is we're going to transform this into a polynomial. So we're going to make that our characteristic polynomial, p of r, is going to be 6r minus 7 times r plus 1. And then we'll turn that into a characteristic equation. So that's characteristic polynomial. And then we have p of r, right, which is 6r minus 7 times r plus 1 is going to then get set equal to 0. That's your characteristic equation. And then we're just going to solve for r. So 6r minus 7 will equal 0. Okay, that gives me that r is equal to 7 over 6. And then r plus 1 is equal to negative 1. And that gives me then that r equals negative 1. Okay, then we use those, we transform each one of those into y1. Our first solution will be e to the 7/6 x, and y2 will equal e to the negative x. Okay, and since this is a second order differential equation, right? Second order, you can see that it's going to have two of those linearly independent solutions. Okay, and so our complete solution is going to be y equals c1 e to the 7/6 x plus c2 e to the negative x. Okay, let's just go through and let's check, make sure that these are in fact our solutions. So we've got, again, we're going to have 6d squared minus d minus 7. And this time we'll take an e to the 7/6 x. And so this will equal 6 times the second derivative of e to the 7/6 x minus e to the 7/6 x prime minus 7 e to the 7/6 x. Okay. And this is going to then be equal to 6 times 49 over 6 e to the 7/6 x minus e minus 7/6 e to the 7/6 x minus 42 over 6 e to the 7/6 x. Okay, this guy here is going to end up equaling 49 over 6 e to the 7/6 x. And these guys are going to be equal to 49 over 6 e to the 7/6 x, right? When we combine these two, that one and that together is going to equal 0. All right, so check. That is a solution to that differential equation. Second one, e to the negative x. Okay, so let's take e to the negative x. So we've got 6d squared minus d minus 7 e to the negative x is going to equal 6 e to the negative x prime minus e, or double prime, excuse me, e to the negative x prime minus 7 e to the negative x. And this is then going to equal 6 e to the negative x minus e to the negative x minus negative e to the negative x minus 7 e to the negative x, which, combining like terms, is going to end up equaling 0. Check. Also a solution. So our general solution is going to be this guy right here. There's the general solution to the second order differential equation. Done. Awesome. Okay? Now, notice a couple things. If we want to get a particular solution, we'll do another example in a minute. We're going to need to find C1 and C2. So that means that essentially that we're going to have a solution to the first derivative and a solution to the second derivative. Or excuse me, a solution for y of 0 and also one for y prime of 0 in order to give us both C1 and C2. Okay? All right. That's it. Right? What did we do? We went through, we said, okay, we're going to start here. We've got our differential operator. It's homogeneous, so it's going to equal to 0. Right? We'll put in a y right there. From there, we factored, right? Because we had constant coefficients, we could do that factoring. Then we had our characteristic polynomial, which we turned into a characteristic equation, and then we solved for our r's, which are going to end up being the power, well, they're going to be the coefficients in front of the x term for each one of our powers of e. All right? And so hence, I got, right, r equals 7/6, then r equals -1, right? E to the 7/6, e to the -x. There it is. And then I combine them to make my total general solution. Y equals C1 e to the 7/6 x plus C2 e to the -x. It doesn't matter which one's C1 and C2. It doesn't matter. You can do it either way. So consequently, that's what you do. Okay? And then I just went through and I checked. All right. That finishes that up. Quick and dirty. 5 minutes. All right. We'll do another one.